Hello everyone, my name is Muhanag Hijazen. I'll be talking today about modeling and controlling for DC motor. What is a DC motor? DC motor is an electrical motor that's powered by direct current, such as batteries, electrical machines. Uh, those kind of electrical machines are just to convert electrical power into mechanical power. DC motor can be anything from small motors on RC cars to large motors on controlling pumps and other electrical machines. So how will I design my DC motor? How would I explain my design? So I'm going to show my block diagram model of how DC motor works and label each part of that block diagram. Then I'm going to show you what I'm going to do for my transfer function, how to construct the equation, and how to solve it in MATLAB to find the roots and solving transfer and finding everything. So that is just a small graph to show you how the angular velocity here and torque over here, L, impedance R, and V naught. There's a better graph, or there's a better figure over here showing you the angular velocity, over here, the viscous friction, torque, the impedance, resistance. So before we go, I'm just going to make sure that you fully understand how a DC motor works, to be exact. So from my previous slide, I explained this DC motor, and this is now has more description. So as we all know, motors are electrical machines which convert electrical energy to mechanical energy. That's from previous slide. It's the same principle, but the way it works is different. So how does a DC motor work, to be exact? So whenever a current carrying conductor is placed in a magnetic field, it experiences mechanical force. The direction of this force is given by Fleming's left-hand rule, and its magnitude is given by F by L. So B will be your magnetic flux density, I will be the current, and L will be the length of conductor within the magnetic field. So that's my block diagram, and as you can see, I have my impedance, resistance, and the rotator, and the motor torque constant, resistance, everything. So this is my system equation, and I start drafting each equation, plugging in till I found that the equation at the bottom, and that equation is really common for most DC motors, as I found out. So how did I start constructing MATLAB? First of all, I need to have parameters, set my parameters. The parameters you can see on your screen would be parameters active from the internet, because I don't know how to set my parameters. I'm going to do that. So it told me it needs a settling time of 0.3 seconds, a percentage overshoot of 5%, an aspect frequency of 2.3 radians per second, and a damping ratio of 0.702. So I plugged in everything, the J, B, K, R, and L. Those are the J as a rotator meter, B the viscous friction, R resistance and impedance. Those I got them same thing from the internet. Those they should be given to you. And for the overshoot, as you can see here, the 0.005, that's because of the 5% divided by 100. That's the setting time, which was 0.3. Zeta, it's the damping ratio. Wn, the natural frequency, and I have WD. WD is the natural frequency times 1 minus zeta square root. So after plugging those in, this is my MATLAB. After putting everything, I will get a total of 4 graphs, 2 of them for an open loop and 2 of them for a closed loop. So this one is an open loop step response showing amplitude and time, and this one would be a root locus, same thing, open loop. Here I just want to show you the difference between what's the for the open loop and the closed loop. See here the steady step response for an open loop, and this is step response for a closed loop. And you can see for a closed loop it's 0.09, that's where it stopped. For the open loop it's 0.1. For the root locus, as you can see, it ranges from negative 10 till negative 2, and the height from 6 to negative 6. And you focus on the units, that's in second power of minus 1, second power of minus 1. And then here this is closed loop root locus, and as you can see, it ranges from the range differ from negative 6 to 5, and here touching 0 to negative 2. So those are the differences. This is like just an overall of what I did and things I found out on my report. There will be more details. Those are my references. If there's any questions, just email them to me and I will answer them as fast as possible. Thank you.